Hello, my name is IMRAN HAZAMI bin FAIZAL 102602, and I'll be presenting the part for introduction, objectives, and problem statement of our project. First of all, this project aims to choose the best material for producing a machine bracket. The material is to be chosen between steel, low carbon aluminum, and brass. Material choice is one of the most critical decisions in producing high quality goods. It directly affects longevity, durability, and functionality. Poor material selection can lead to serious failures if standards are not met. And for the objective of our project, it is to evaluate steel, low carbon aluminum, and brass by cost, weight, and sustainability, to design a MATLAB-based decision support tool for material selection, to apply sustainability metrics in engineering decision aligned with SDG 9, to suggest the most suitable bracket material balancing performance, cost, and sustainability score. And for the problem statement, it is to choose the right material for a machine bracket that affects durability, cost, and sustainability. The workshop must decide between steel, low carbon aluminum, and brass, each with trade-offs. To avoid inefficiency and poor sustainability, the challenge is to select the best option by comparing cost, weight, and sustainability score in line with SDG 9, using a MATLAB-based AI tool for data-driven support.
Hello, my name is ZAFIRUL ID and my metric number is 102523. I'll be explain about the algorithm step. The algorithm starts by defining the three candidates materials, which are steel, aluminum, and brass. Next, the user inputs the volume of the machine bracket and provides the density, price per kilogram, and sustainability score for each material. Using these inputs, the program calculates the weight of each material by multiplying the volume by the density and then determines the total material cost. After that, a decision score is computed for each material based on the selected criteria, taking into account factors such as cost and sustainability. The algorithm then compares the decision score of all three materials to identify the most suitable option. Finally, the program displays the weight and cost of each material and recommends the material within the highest decision score, together with a justification for why it is the best choice for the machine bracket.
My name is Putera with the metric number of 102914, and I'm going to present about the flowchart. The flowchart starts by defining the material type, which is steel, aluminum, and brass. After that, it's calculating the volume of the bracket, and next is to determine the density for each material. And after that, process is the determine the price per kilogram. And next is assign sustainability score, which is out of 10. And then next process is to calculate the weight, which the weight is equal to volume times density. And next is to calculate the cost, which cost equals to weight times price. And after that is the process of calculating the decision score. And after that is the determining which what is the highest decision score. If there is no, it will be written back to calculating the decision score. If yes, then it will continue to the next output, which is display cost and weight of all material. And next is to display winning material, and lastly to display justification statement. And our process ends there.
My name is Muhammad HAIZAM bin ELLI, matrix number 102716. I will explain about the pseudocode. From steps 2 to step 7, we establish our initial parameters. We define our material, which is steel, aluminum, and brass, alongside its volume, which is fixed at 0.000624 cubic meters. We then put the properties of the material, which includes the material densities, the market price per kilogram, and the sustainability scores out of 10. Next, from steps 8 to step 10, we calculate the weight of the material, which is volume times density, and the total cost of the materials, which is the weight times unit price of each material. Next, we continue steps 11 to step 14. We standardize our values by calculating the normalized cost and normalized weight vectors. by using the defined criteria weightings, which is 0.33 weight to cost, 0.33 weight to weight, 0.34 weight to environmental score, to calculate the best final score. Next, in step 15 and 16, we find the highest value from the best final score that we get from the previous steps. Lastly, from step 17 through 20, the program display the result, the winning material, and the SDG justification. And lastly, steps 21, the program ends.
Now, for the program's designs in the MATLAB, it has four main functions. The first one is to calculate the weight needed for each material to produce the product. The second one is the total cost of the production. The third one is to calculate the sustainability score of each material based on their carbon emission. And lastly, to decide which material is the most suited to be used as the machine bracket. Now, to kickstart with the program will display the materials that will be used. And in this case, the program will show steel, aluminum, and brass. There are a few fixed variables in this program, such as the volume, the density, the price of each material, and the carbon footprint. In the first part, the program will calculate the weight needed for the product of each material. And it will determine the lightest material out of all three. And in the second section of the program, it will calculate the cost of the production based on the weight that the program had just obtained. And it will determine the cheapest material out of all three again. And on the third section, it will determine the best sustainability score based on the lowest carbon emission out of all three, and it calculate the carbon emission by using the weight of each material once again. So weight is very important in this program. And the highest score will be the material that emits the least carbon upon production. And on the fourth section of the program, we can see that it is normalizing, standardizing the score of each category so that the program can determine which material is the best material to be used as the machine bracket out of all three categories of weight, the cost, and the sustainability score. And in the last section of the program, we can see that it is displaying every category, every the cheapest, the lightest, and the best sustainability score of the materials. And lastly, it will show the it will decide which material is best as the machine bracket.